Well, welcome to the last lesson in our unit. We have studied volume, and we're going to finish up with studying volume today. So our goal today is to calculate the volume of cones, and cones are everywhere in our world. From traffic cones to ice cream cones, oh, I love ice cream cones, to Christmas tree looking trees, because they're all so pointy and cone shaped. And then you've got the spires on buildings. Cones are lots of places, like everything else. So here's what we've covered. These are the volumes that we have learned how to calculate. We've done the rectangular prism. We did the cylinders. We've done spheres, and today we're going to do cones. And don't forget, volume fills. Okay, so that's what we're talking about, filling up, putting stuff inside or filling up a three-dimensional object. So don't forget, when we give our answers, they're going to be in 3 dimensions. So you're going to have something cubed. So let's start out right away with the volume of this particular cone. Now we have a new equation, formula to use. And again, you don't have to memorize all of these. They are going to be available to you on the help sheets. So make sure you use those help sheets. So here's one where our radius, as you can see, the radius is the distance from the outside of this little circle here to the center. Okay, our radius, R, is 5. Our height right here is 13. And all the rest of the stuff we know. We know what a 1/3 looks like, what is. Okay, so 1/3 times pi times r squared. Whoops, I wrote r instead of 5. Ooh, nice. Let's get the eraser out here and get rid of the r. There we go. Now, oh yeah, did it go back to the pen? No. Okay. Here we go. So, we should have put 5 there, not the r. 5 squared. There we go. Times h, which is 13. And remember, this is feet squared times feet. So our final answer is going to be feet cubed. Okay? That's how that cubed comes from. So 1/3, we're going to just leave 1/3 times pi. Actually, let's just do it on a calculator. You don't need me to write this all out. So clear my calculator out. And I can do the 1. And then again, just to remind you, our button to make that into a fraction is right there. 1. Press that and type the 3. There's my 1/3. That's what it looks like on our school calculators. Okay, 1/3. Say times. I'm going to punch the pi. And then times 5 squared. And again, the button to get the squared is that x squared there. And look at that. 5 squared is 25. Times 13 equals, and here's what I got, 340.339, okay, 339, and it keeps on going. What if I wanted it rounded to the 10ths place? If I've said to the 10ths, and I'm going to write that down so you can understand what I'm saying, 10ths place, then it would be 340.3. That's the 10ths place. If I wanted it to the 100ths place, that would be 340.3. And then take a look at that 100ths place. That's our 3 right here. Look over here to the next digit. Is that digit 5 or more? Then we raise that score. So yes, 5 or more. It is a 9. So I'm going to make that a 4. So this would be our final answer written to the 100ths place, which is usually what we're doing on most of these questions, I think, in this lesson and in the upcoming questions. Oh, there it is, 100ths place, your turn. All right, by now you should understand the difference between those estimates where we're rounding to a certain place value and an exact answer because of pi being in there. And now we have a complication of the 1/3. So even if I say sometimes if we want to do an exact, we might not be able to, because remember, fractions like 1/3 are not an exact number, but we're going to leave it as that for now and see if we can get an exact number for this. So let's take a look. I'm going to fill in everything like I've been doing. So we've got 1/3 pi, which we are going to leave as pi because I want to go with the exact volume. If I try to multiply that pi, I definitely won't have an exact answer. So we're going to see if we can end up. Whoops, I did it again with the r squared. I wanted to write in the 12 there. Let me get rid of that. There we go. There we go. Oh. Yeah, I want the pen. Okay. 12 squared times the height, which is 13. Okay. So now let's see what happens. We're not going to multiply our pi. Let's see if we happen to have numbers here that are going to give us an exact volume. And I think in general, I'm not going to give you something that isn't going to. If I say exact, then you should be able to come up with an exact number. So doing the 12 squared, I'm going to do that first, I guess. Oh, it doesn't matter. Now, let's go in order. All right, 1/3, okay, using the fraction button, times 12 squared times 13. And that equals a nice round, even number that terminates. And it didn't even go into the decimals. It's 624. Very nice. 624 pi. So we got a nice even number, and that is an exact volume. Anytime we can get a nice terminating decimal, and in this case a whole number, we know we have the exact volume if we just leave it with the pi as its symbol. All right, now you give it a try. See what you do with this one. Okay, now let's take a look at this kind. You've also seen this before. Notice we don't have the radius. Okay, one more time. I know you know this already because we've already done this with cylinders and spheres, but we're going to do it one more time. We are working, if I can find I'm trying to find my pointer here. Here we go. We've got a diameter. This is going clear across, so we need to cut this in half. Half of 6 is 3, so r is 3 yards. Plug that in. 1/3 pi r squared. 3 is what we're squaring, not 6, and that's all times 14. So again, I'm not going to multiply because it says exact volume. So we definitely don't want to use the estimated value for pi. So I'm writing that down. Now let's put in the rest of it. You can even do what I like to do instead of using the fraction button on here is I'll do the 3 squared times 14 and then divide by 3. Just a little less typing. So 3 squared times 14. And you can do equals or not. It doesn't matter. Equals. I kind of like to do the equals just to see what I get. And then divide by 3. And we get 42. So that one is 42 pi. So pay close attention anytime you're doing a problem. Make sure you've actually got the radius. Don't just go with the 6. Okay, make sure if it's all the way across, then you know you've got your diameter and you've got to cut that in half before you can plug it into our formula. Okay, now you've got one to do yourself. Cut that diameter in half before you do it. Here's another one. Give this one a try too. Pay attention. Do you have the radius or do you have the diameter? One more and we're going to call it quits. At least until I make you do some try-its and prove-its and stuff like that. But last one. Now this one's an interesting one. This one's really, really sneaky because notice I said round your answer to the nearest hundredth if necessary. But look at all those answers. They all have pi in them. I wonder why. Could it have something to do with that 1/3 going on there? Okay, I really gave it away. Pay attention. Be careful. You can do this. Well, that's it, guys. We are finished with all our lessons on volume. Oh, boy, we really packed a lot in, but you know, it's really not hard. Plug those numbers in, plug them into that calculator, chunk, 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 out it comes. You are going to ace this test. No worries. Thanks for watching. Have a great day.